for example, it's you could apply a primary key constraint on whatever field or fields you want to make the primary key. So that way, like no transaction would be able to add a new row to that table that has an already existing that has an already existing value for that primary key. You won't be able to add a duplicate primary key value. So that's like one constraint, and that's like I guess the most important one. You don't want any table that has like the same two values for a primary key. So you'd apply a primary key constraint, and that would prevent any duplicate primary key values from being added to this table. Another type of constraint would be, a common constraint is you wouldn't want any orphan data in your table. Like if you have two tables that have a one-to-many relationship, you don't want to have, a table on the many side that references a foreign key value that doesn't exist in the parent. So I kind of use the example of, let's say, you have in the titles table and the tracks table, like a bunch of tracks that belong to a title that doesn't exist in your database. So let me bring up the table. Select all from titles. So we only have these 6 distinct title IDs in the titles table. If I add a bunch of tracks to the tracks table that have, like, for example, title ID equals 8, that would be, inconsistent or incorrect data, because then you'd have, orphan data, a bunch of tracks that don't belong to any album. So that would violate the consistency principle, because, that would violate referential integrity. You're referring to something that does not exist. So that's why you'd put like a foreign key constraint on the tracks table, saying that, it must, any title ID in the tracks table must refer to an existing valid title ID in the titles table. I hope that answers your question.
Yes.
I think it did cover one more constraint as well. It's called check, but it's not supported in the Uni server. Let's say I did something like create acid test. That sounds like something else, but never mind. Integer, not null. I have a field B. I've typed integer and it's not null. And then I'll put a check constraint. Check. And the constraint and the predicate will be A plus B equals 100. So I create a table with 2 rows, and with 2 fields, field A and field B, both of them are integers. And I can apply a constraint that for each row in this table, both of those fields have to add up to 100. So I have that constraint. Any row that I enter this table will have to have a value of A and B that add up to 100. And this constraint here will reject anything that violates that. So it would accept, 64, A equals 64 and B equals 36, but it won't accept, A equals 64 and B equals 42, because that would add up to, more than 100. Usually the type of constraint you'd see for, a check constraint would be something like, a database table for a banking system, something like, check balance greater than 0, greater than equal to 0, can't have a negative balance. So that would prevent any transaction that would occur that would prevent any transaction from being performed on the table that would result in a negative balance if you did something like check balance greater than or equal to 0. So that's what I mean when I talk about constraints. And constraints are just like the primary tool we use to enforce consistency, prevent any invalid data from being added, or prevent any invalid data from being committed to the database. It's 7:28 now. I think that's enough break. So let's continue on. Okay, so I said I wanted to review homework 6 as well because we haven't had a chance to review your work on data manipulation language and data definition language yet. Okay, so I had 5 questions for this. The first one, basically adding a new track to the tracks table. Let's see. I think someone needs to go on mute.
Yeah, sorry about that. I muted myself.
No worries. Okay, so as I mentioned before, there are 2 different ways to add a new field. There's 2 different ways to add a new record to a table. We use the insert command. Either insert into table name, and then I can specify which values will receive data. This part's optional. Or specify which fields should receive values. And then values. And then the list of values that I want to supply for each of these fields. Or whatever values I specify here have to be in the same order and the same type as the list of fields that I supply, if I supply fields. If not, they have to be in the same order and the same data type as the way the fields are presented in the table. And the alternate method is insert into table name. You can choose to specify which fields will receive data. And then insert using the results of a query. So this one I usually use if I'm manually inserting, a new record, and this is used for inserting one record at a time. Inserting with the results of a query allows me to insert several rows at once. So 1, it allows me to insert several rows at once. And then 2, it allows me to both insert and look up information from another table at the same time. It allows me to look up information from another table and insert it simultaneously. So situations where I would do that is if I have, incomplete information to add. So if I look up this information, I'm adding a new record to the tracks table. Oops, I didn't mean to do that. Oh well, I'll just keep that table for now. So question 1, select all from tracks. So in the question, I provide the following information. I don't provide the title ID, but I provide the title, time flies. I provide the track number, 11th track, the track title, spring, the length, 150 seconds, and I say that only the MP3 flag is set to true. So I have everything except for the title ID. So I'd insert to using this syntax. So it's insert into tracks. I won't specify the fields because I'm going to add values for every field. But in this order: title ID, track number, track title length, seconds, MP3, and real audio. Actually, let me do this first. Describe tracks. Okay, so insert into tracks, and I have to specify the fields in the order that they appear when I do. Describe tracks or select all. Title ID, track number, track title length, seconds, MP3, and real audio in that order. So using the results of a query, select. Now I don't know the title ID of Time Flies, but I do know the title name, so I could use that to do a query. So select title ID, and the others I could just use literals, constants. I have the track number 11, track title spring, length seconds 150, MP3 is 1, and real audio is 0. So while I'm inserting this, I'm going to select title ID from titles, where title equals Time Flies. Now, if I want to insert this record into the table, sometimes it's best to run the select clause first by itself before I include insert into. So I'm just going to get rid of that for a second and just run this query by itself. So title ID is 4, because if I look at my titles table, Time Flies has title ID 4. So if I want to add this to the tracks table, add this, insert into tracks, and then the results of this query. And now when I look at my tracks, that new one's at the very bottom. Title E equals 4, track number 11, title spring, 150 seconds length long, and the real audio and MP3 flags set as shown. And I did get a few questions. How come it gets stored to the bottom instead of getting stored into the table? It doesn't matter if the data is out of order, because when we query this, kind of stuff in the real world, we'd usually use order by. Yeah, we'd usually use order by, so it would be in the correct order when you run the query, anyways. So that's the first question. The second one, I asked you to recreate the entire members table as a new table called members2. So if you remember the syntax for creating a new table, create table name. And this is probably more of a cumbersome question than anything else. But when you create a table, you have to define each field in the table. So for each field you want to define, you have to specify the following: field name, data type, and whether or not it can receive null values. Do that for each field you want to define. Field name, data type, and whether or not it receives null values. And then at the end,
you can see that for a particular lesson, they include like reading, pronunciation, grammar
constraint
summaries,
type,
grammar exercises.
and then the fields that you want to
So
apply
I'm
it to.
going to focus on the second part here.
And you do that for
Um,
each constraint you want to define.
so let me advance this.
Now with the members table, I was only, this is before we covered constraints, so I just want you to create the members table
But you can
as
get an idea of what this looks like when you enter it. Okay,
create the table with
so
just these
for
fields.
every grammar unit lesson, they
And yeah, I'll upload this to Canvas before the midterm. So
memorize a topic.
no worries there. Yeah, I'll upload the answers.
Can you go ahead and play with
Yeah,
these
I'll upload my
so you
whiteboard
can
notes and the answers to Canvas before the start of the midterm. So I want you to, recreate the members table. So I would expect you to do, create table members, and then for each of these specify field name, data type, and whether or not that you receive no values. Field name, data type, or whether or not that you receive no values. Some of the more intrepid amongst you kind of realize that there's a certain way to do questions 2 or 3 simultaneously. Question 2 was to create a new table called members 2 with the same fields as the members table. Question 3 was to populate that table with the contents of the members table. So that would have been, create table, members 2, and then supply this information for each field from the members table. First name, string, null, last name, string, null, etc., etc. And
last 7 digits of the old phone number. And when we have functions like left, right, and substring, to extract a substring from a larger text string, so we get the last 7 digits of the home phone number with the function right. The home phone number will take the last 7 digits. Remember the syntax for right right and left take as arguments a string and an integer. And substring will get a string and 2 integers. String is the text string you want to pull and extract from, and integer is the length of the substring you want to extract. For substring, the first argument you supply the string is the string you want to extract a text string from. The first integer is the starting point, and the last integer is the length of the substring you want to extract. So I'm going to concatenate the new area code with the 7 digits from the right of the previous home phone number.
So we go from 277.112.3943 to 899.112.3943. So that's how we update the phone number. Concat the concatenation of the new area code and the remaining 7 digits of the old phone number. Now the other way I saw you guys do this one, I saw one that was particularly creative. Home phone plus 622 followed by 7 zeros.
No way. That's awesome.
And it's the same result. So I mean, I saw a lot of you could use a replace, but I thought this was the most creative alternate solution.
same address information as Doug Finney over here, where first name equals Doug and last name equals Finney. So this is the new record I want to add to the artist table. So insert into artists. Syntax for adding using the results of a query. Insert into table, and then your select statement. So insert into artists, and then copy paste this query. So now when I do select all from artists, so I have the new artists in the table. Okay, so that was just basically giving you pretty much a setup for the extra credit question. So now I've added a new artist to the artist table. I have the two members who belong to it in the members table. Now I just need to update the cross-reference table accordingly. So, too many fields. Just make sure I didn't record. No. Okay. So these two members with member ID 32 and 19 and this